Deep in the southeast corner of Illinois, along the Wabash River Valley, is an escarpment called the Meadowbank. Straight as an arrow for over 8 miles and 20 feet high, it separates an ancient lake plain from the Wabash River floodplain. It's very unusual to have such a long, straight embankment and soft sediments. Our research question this year has been to determine how the Meadowbank was formed. One very intriguing cause immediately comes to mind: earthquake. Like the Meadowbank, earthquake fault scarps tend to be long and either straight or gently curving. And adding to the intrigue is the realization that this is earthquake country. The Meadowbank is located in the southern part of the Wabash Valley seismic zone that has produced several damaging earthquakes within the last century. It's also within striking distance of the devastating New Madrid earthquakes from 1811-1812. People living near the Meadowbank witnessed large sand-blow fields and experienced very intense shaking from those earthquakes. Searching the riverbanks, one can find evidence of similar sand-blow events from older earthquakes, apparently epicentered in the Wabash Valley, not to the south near New Madrid. One of those sites is within view of the Meadowbank. Finally, looking at the structure map of the Wabash Valley area, you can see that the Meadowbank is perfectly aligned with the Phillips fault, but displaced about a half mile to the east. There's even a bend in the Meadowbank following a bend in the fault. And so I am led to the inevitable conclusion, and believe that I can now say categorically, without a doubt, that the Meadowbank was caused by neotectonic reactivation of the Phillips.
Oh, no, hold on just a minute here. As it turns out, there is a coal mine directly underneath that fault, right? The Meadowbank, excuse me. We can check to see if in fact there truly is. I'll do that, sorry. Well, miners removed the coal beneath this area, and they did run into the Phillips fault, but they found no faulting beneath the Meadowbank. In fact, take a look at this cross-section here on the left, and it shows that the Phillips fault is too far away. This ain't the case, guys. So whatever the Meadowbank is, it can't be because of a fault offset in the bedrock. And from that, I can say that the Meadowbank was not caused by an earthquake. So if it wasn't from a Meadowbank from a bedrock fault, then what could it be? Let's take a closer look. And now, I'm Drew Phillips. We collected and analyzed geophysical data, cores, and LiDAR data to solve this mystery. For example, resistivity profiles show that the sediments to the west of the Meadowbank are different from those to the east, but no evidence for faulting. Closely spaced borings show that the gravel and sand layers below the Meadowbank are flat-lying, but with no sign of vertical offsets. And this sediment dates mostly from the last glaciation, and more recent stream deposits form a surface veneer. Furthermore, LiDAR data shows that the Meadowbank is not unique. Although it is distinctively straight, long, and high, a family of similar landforms can be identified along the valley. These each occur at a tributary confluence and are terraced above the Wabash Valley fill. So here's what we think happened. During the last glaciation, the Wabash River was a major outlet of meltwater, shown here at its maximum extent. Outwash from the glaciers flowed south and filled the valley. One consequence is that, of the outflow is that lakes, called slackwater lakes, formed when high sediment loads filled the main valleys, like the Wabash and Ohio River, and then dammed the mouths of the tributaries. Later on, during ice retreat, these large lakes dammed by moraines and ice formed along the glacial ice margin. Glacial Lake Maume, which you can see here, which is ancestral to Lake Erie, drained down and into the Wabash River Valley. Sometimes those dams broke, and like this modern example from Greenland, the lake outburst flooded the ancestral Wabash Valley. And these discharging torrents inundated the valley for days to perhaps even weeks. The massive floods would transport large volumes of water and move large amounts of sediment. And we contend that the Meadowbank and similar features at the mouths of these tributaries were eroded out of the valley fill as the floods waned. So, we would say that the Meadowbank is no longer so mysterious. The distinctive scarp that is there was formed when late glacial floods, constricted by bedrock valley walls, lowered the valley fill and scoured out these tributary deposits. So we say the Meadowbank is explained.